In this video, we're going to be taking a look at the idea of angle between two planes in space. So, if we know two vectors that are normal to planes, so let's say we have a plane P1 and another plane P2, and then we know normal vectors to those planes, N1 and N2. What we can do is we can just use our formula that we used for the angle between two vectors. All right, and you might remember that this was in one of our very first sections. We were able to find the angle between two vectors. And that's exactly what we're doing. We're just taking an extension of that, and we're taking the angle between two planes because we're taking the normal vectors. All right, just like we looked at before, if the dot product between the two normal vectors is 0, that means the planes are perpendicular. The planes are parallel if n1 and n2 are scalar multiples of one another. So let's go through and take a look at 3 separate examples to determine if the planes are going to be parallel, perpendicular, or neither. So we have this first plane, 3x plus 1y minus 4z is equal to 3. Negative 9 minus 3y plus 12 is equal to 4. All right, so one thing that we can do automatically is we can very easily get a vector that's perpendicular to the plane. Because remember before we had this idea of direction numbers with lines. Well, the numbers in front of x, y, and z, all the coefficients, are going to produce a normal vector to the plane. So in other words, n1 is going to be 3, 1, negative 4. And n2 is going to be negative 9, negative 3, and 12. All right. Now, we can determine if they're going to be parallel, perpendicular, or neither very easily. And I bet you if we take a pretty good look at both of the vectors, then we can very easily see that there might be a scalar that we can multiply n1 by to get to n2. And I think that negative 3n1 is going to be equal to n2. Right? So if I was to take 3 times negative 3, that would be negative 9. Negative 3 times 1 is negative 3. And then negative 3 times negative 4 is positive 12. So indeed, what we can say right away is that without doing any work, that these vectors are going to be parallel. So P1, P2 are parallel since negative 3n1 equals n2. So that one was really easy. A second example, maybe not so easy, is the plane P1, 3, 2, negative 1, x, y, and z respectively equals 7, and then 1x, negative 4y plus 2z is equal to 0. So this one doesn't look like it's going to be parallel. All right, so let's find n1 and n2. Now n1 is going to be 3, 2, negative 1. n2 is going to be 1, negative 4, 2. One of the things that we did earlier when we found the angle between two vectors is we started with the dot product. If the dot product is 0, then we stop right away and we can say that the planes are orthogonal, or in this case the vectors are orthogonal, meaning the planes are perpendicular. So n1 dot n2 is going to be equal to 3 times 1 plus 2 times negative 4 plus negative 1 times 2. That's not 0, unfortunately for us. That's going to work out to be, I believe, negative 7 if we computed that correctly. All right, so what we are going to have to do is we're going to have to finish out the formula. So we're going to take the absolute value of the dot divided by the magnitude of n1 times magnitude of n2. Okay, so let's find magnitude of n1. That's going to be square root of 3 square plus 2 square plus negative 1 square. And that's going to be root 14. Magnitude n2 is going to be the square root of 1 square plus negative 4 square plus 2 square. and I believe that's going to be root 21. Finally, we go through and we can try to figure out what the angle is going to be. So remember our formula, cos of theta, we're going to take the absolute value of -7, and that's going to be square root of 14, square root of 21. I don't think this is going to work out exactly, although we could simplify this if we really chose to. I'm going to elect not to do that, just because I know that 1 over root 6 is not one of the special angles that can be produced from cosine. But again, you could simplify this, and we're not going to do that. So theta is going to be equal to the arc cos of 7 over root 14 times root 21. And I'm going to approximate this to the nearest hundredth of a degree, because I can. And just give me one moment while I shove this into the calculator. 7 over root 14 times root 21. And I get 65.91. All right. And you could plot the two planes and then kind of get an estimate about the angles, but at that point, by the time you're done drawing it, it's probably easier just to go back through and check it 3 times, and you'll probably get the same answer. All right, for letter C, our first normal vector is going to be 2, 0, -1. Our second normal vector is going to be 4, 1, 8. Again, it doesn't look like that there's any non-zero scalar that we can multiply by each one to get to the other, particularly because P1 is missing a y value. So let's try the dot product. So it's going to be 2 times 4 plus 0 times 1 plus -1 times 8. And this indeed looks like it's going to be 0. There shouldn't be a check there, but it makes the problem a lot easier. Because it's equal to 0, we know that the two planes are perpendicular. So we say N1 and N2 are perpendicular, which means that the angle between the two planes, theta, is pi halves. All right, and again, we automatically know that it's going to be perpendicular since N1 dot N2 is equal to 0, and the dot product of any two vectors equals 0, forces that to be a perpendicular relationship between the vectors or the planes that those vectors lie in. So the last video we're going to take a look at after this one is going to be looking at the distances between planes, points, lines, etc.